So can you see it?
No, not yet.
Okay. Now?
Yes. Yes.
Okay. Perfect. Okay. Good morning. My name is Giuseppe Stragapede, and I'm ESR number 1 at the Autonomous University of Madrid. My supervisors are Professor Ruben Vera Rodriguez and Professor Ruben Tolosana from the BIDA lab. Okay, I come from Bari, the administrative center of the southern Italian region of Apulia. I'm a 27-year-old information technology engineer. Have obtained my bachelor's degree in electronics and telecommunications engineering and my master's degree in electronics engineering, both from Politecnico di Bari, the amplest technical university in Bari. Two particularly enriching experiences of my master's degree were my time at the University of Glasgow, where I spent 1 term as an Erasmus student in 2017, and my master's degree thesis internship carried out at Teleperformance, a worldwide company in the field of customer relationship management. After graduating in 2019, I joined Masmec, an Italian company in Bari specialized in the design of automated machines in the biomedical and automotive field. I was appointed as a computer vision engineer in the automotive branch. As of today, I'm very happy for having joined this consortium and the Autonomous University of Madrid, and I'm motivated to commit my best effort. In particular, my ESR position is about quantifying privacy with application to mobile user interaction. The specific research topic of this position is the development of theory and methodologies to quantify privacy in the context of biometric data acquired through the interaction of the user with mobile devices. A systematic study of the state of the art will be carried out, as well as a collection of multimodal datasets. I will also focus on new metrics to quantify privacy in continuous authentication schemes. I will be spending my secondments at the University of Kent in Canterbury in the United Kingdom in 1 year and at the Fraunhofer Institute for Computer Graphics Research in Darmstadt, Germany in 2 years. The significance of my research originates from the fact that biometric data is extensively used to authenticate users, especially in mobile devices. It is convenient because the authentication information requires no mnemonic effort, such as in the case of passwords, nor additional devices. And it can deliver a more secure schemes compared to traditional methods. Mobile devices in general are equipped with many different sensors that record and classify the user's physiological traits. On top of that, the different application and network usage and GPS position can be logged to provide an additional security layer tailored on the legitimate user's habits and routines. This category is, on the other hand, what is called behavioral biometrics. So this raises a concern in terms of privacy. How much is privacy compromised by mobile authentication systems? The case of biometrics is, of course, especially crucial in terms of privacy because such traits are permanently associated with the user. I am primarily going to focus on multimodal systems. As perceivable, multimodal systems integrate the evidence presented by multiple sources of information, on the contrary to unimodal continuous authentication systems that rely on a single source of information and suffer more from some inevitable problems, such as noisy data, non-universality, as in the case of a single sensor not being able to capture meaningful information from some users. We have intra-class variation, since a single user's data changes over time, and spoof attacks, for example, using a picture in front of a camera. So this leads to another relevant thread in research about fusing information. There are multiple approaches, directly on the raw data, on extracted features, or after each classifier has reached a decision independently. In any case, an adaptive fusion approach should be maintained since some of the inputs might not be available at all times. Another key aspect is continuous authentication. Consider this. after the initial authentication, most systems do not require the users to verify their identity again, as long as the device remains active. In such way, an intruder could potentially gain much information, having at their disposal a long-lasting amount of time. In general, on the other hand, the impact of the authentication phase on the device usability should be minimal, since it has been shown that users tend to quit using security mechanisms. A security versus usability trade-off generates from this evidence. Continuous authentication does not require the user to actively take part in it. It should run in the background, and it is in fact also known as implicit authentication. The concept of privacy in general has had many formulations in the course of time. I'd like to mention two that have been or are directly linked to rigorous formulations for technological purposes. The first one is differential privacy, which states that the user will not be affected by allowing their data to be used in any analysis. In other words, differential privacy ensures that any sequence of outputs of a system is equally likely to occur, independently of the presence or absence of any individual. The second definition is based on a multidimensional space in which every dimension has a concrete meaning in the scenario of sharing any kind of personal data to a data collector party. One is visibility, that quantifies who has access to personal data, as in the case of a third party. Then we have granularity, which refers to how specific this data is. We have that allows us to evaluate if the data have to be used for a one time only for a specific purpose, or many times for different purposes, and so on. The fourth one is the retention time granted to the data collector party. Broadly speaking, metrics are quantities that help us positioning entities with respect to each other in a common space. There are many metrics in the biometrics system space. There is accuracy and many related quantities that help us evaluating the performances of the authentication systems. There are also other quantities depending on the scenario, latency of continuous authentication systems, for example, or how much mobile authentication protocols impact the smartphone resource usage in terms of device battery consumption and the processing speed of the device, especially, again, for continuous authentication. Besides the numerical values that help us comparing the different systems, there are also some evaluation criteria. Before the aforementioned security, with different scenarios that should always be considered, the ISO has issued a document on the matter of ergonomics of human-system interaction, and the concept of usability, with its many facets, can be applied to authentication systems. There are more metrics related to the protection of private data. One is privacy leakage, that refers to the leakage of information from the biometric system if an attacker has access to the biometric signal. A meaningful example is deducing whether a user has a particular heart condition from their ECG. We have non-invertibility, which is the property of a biometric feature of not being reconstructible from the associated data stored. We have revocability and non-linkability, in which the data stored can be revoked and the new one can be generated, never linkable to the original user. And in order to evaluate privacy in the field of biometrics, the starting point is datasets. I mentioned here two examples of publicly available biometric datasets. One is UMD-AA02, created by the University of Maryland, which is a well-known biometric dataset consisting in around 140 gigabytes of physiological and behavioral data collected over a 1-week time span. The volunteers involved in this study used their research phone as their primary device for a week in a totally unsupervised way. And the second one I'm going to mention is HumIDB, Human Machine Interaction Database, collected by the members of the BIDA lab. It includes physiological and behavioral traits of over 600 subjects from many different countries and with different devices, also in an unsupervised fashion. I will be joining the BIDA lab, who has been part of the biometric scientific community for many years, focusing on human-device interaction with special regards to continuous authentication, touch, and keystroke dynamics. They also have developed signature and handwriting verification systems in cooperation with bank and educational institutes. Here, in the following weeks, I will be mainly focusing on available databases, reviewing the state of the art, providing a taxonomy of existing systems and their performances, investigating time and continuous authentication schemes, focusing on fusion approaches, model adaptation with time, multiple devices, always from the point of view of privacy preserving. Thank you.
Thank you, Giuseppe. That was almost in time, and because we started late, there is about 2 minutes